want to review, especially what we did last time with the exponential and the log, just to make sure we've got that down. I might even do some review on like, you know, the other stuff that we just tested over, just to make sure we are super comfortable with all the derivative shortcuts, techniques. You guys, you're not going to have to use the definition anymore. But we do need to remember all the techniques we have for derivatives. And then I'm actually going to do a little bit of review on factoring. You know, so like from algebra, but in this next section, we do a lot of factoring. So for example, you know, when you have a quadratic like trinomial and you do the like reverse FOIL or whatever you want to call it, we're going to have to be good at that, because chapter 12 can be a little frustrating because you can understand everything about the actual calculus part of it, but if your algebra is suffering, then it's going to hurt and you're just going to be like, you know, what the heck? I know what I'm doing, but that you're going to have to rely on kind of other math skills too. So we're going to do a little review. So what I'm going to do, I'm going to share my screen with you, and I'm going to pull up a blank page, and we're going to work on things together for review. So let me get this set up, and then I'll share my screen. Let me put some grid lines on this thing. Oh, no, that's too skinny. I can't write that small. Okay, there we go. Okay, so yeah, I'm not videoing. In a minute you'll see the screen, and then as long as you can see the screen, you'll be good. Okay, so you should see my little notebook paper screen here. So let's do some review on the stuff we did last time, because those exponential and logarithmic they're really nothing like the derivatives we've taken before, right? So it might take us a little longer to figure those out. So that's what we're going to do, because we have the time to do it. I'm going to use my rainbow pen. And let me give you a function. So you guys, if I have, let's start basic. Let's just remember the basic rules. If you just have, okay, you guys, I was all about this rainbow pen, but I think it might be a little bit hard to read. Sorry, rainbow pen. Okay, that's a lot better. So if you have the exponential function e to the x, and it's just an x up here, and this is all there is to it. Remember, when you do take the derivative of this function, it ends up just being itself. So we write the e to the x down exactly the same way, and this is the derivative of e to the x. So, you know, like I said in class last time, it's just the easiest derivative you can ever have, because you don't actually have to do anything. There are things that went on behind the scenes. If, you know, I showed you the process of getting to this point, but we don't have to worry about the process, you guys. We can just accept the fact that the derivative is itself. So we had that, but then guys, we looked at cases where it wasn't just x up in the exponent. So let's start, you know, slowly, like we did the other day. So if we have e to the 2x, the thing about exponential functions is the e term as a whole, the process of taking the derivative of the exponential term is the same as the basic process. You guys, the whole term comes down as is. You guys, that happens because it's an exponential function. So I say, oh, e to the 2x. It's exponential, so it's going to come down exactly as is. But the chain rule, you know, shows up everywhere. When we think we want to forget it, we can't, because we keep having to use it, right? So because this is not just x, because it is 2x, I have to take the derivative of this now, and use the chain rule and stick it on the end. So the chain rule, it's a different application here because we're looking at a different type of function, but the chain rule really never changes, right? The rule is you take the derivative of what we call like the inside function and we stick it on the end with multiplication. So then you could finish this off and put the 2 in front because it looks weird the way it is. I don't think you'd even have to. You could probably write it like this, but usually we put the number in front. So we get 2e to the 2x. Let's do another one. You guys, I failed to do one in class, and I think in your homework you probably figured it out pretty easily if you have looked at that. But I never did put a coefficient on e to the x. But you guys, what we know about coefficients is the same in these exponential functions as it was, you know, in the power rule and stuff like that. It's the same all around for any function. Oh, sorry guys, I haven't given you the derivative yet. So you guys, a coefficient works the same no matter what function you're looking at. If it is attached to a term with an x in it, like this, remember it's not a constant, it's a coefficient, and it just comes down. So I bring the coefficient down, and then I take the derivative of e to the x, which is, as we know, e to the x, and this is what we get. So coefficient rules are the same. Like I said, that's something I failed to, I didn't give you an example with a coefficient in front of the e on Monday, but it works how you expect it to work. So what about y equals 4e to the x squared? Let's do this one. So you see an x squared in there, you see the coefficient 4, but you guys, it's the e term that makes your decision on how to take the derivative. So I say, okay, well, this is exponential, so I'm going to take the derivative as an exponential function. This 4 as a coefficient is going to come down in front, or stay in the same front, stay in front, or whatever you want to say. You guys, the e term, even though it's not just e to the x, it's e to the x squared. The whole e term comes down as is without changing. And then we think about the chain rule. And I say, okay, well, that's not just x, so I do need to take the derivative of x squared. That's 2x. So I stick it on the end. And you guys, the way I would complete this problem, technically it's complete here. We have all the pieces. But the way I would probably write this is I would do the 4 times 2 and call that 8. And then I would put the x term in front of the e term. But again, you can write it however you write it. MATLAB's going to take it as long as you have all the correct components. But this is probably the way you would see it. Like MATLAB, if they show you the answer, this is what it's going to look like. And this is what it's going to look like if I do a problem also. Okay, so let's do another one. We'll do one more e, and then we'll review the natural log one more time. So I've got 7e to the 3x cubed plus 4x. I'm really amping it up here. So yeah, there's a 3x cubed plus 4x, you know, I'm like, oh, I'm probably going to use power rule on those terms, which you will, but that's not what you do first, right? The first thing you do is notice this is exponential. So we deal with it as an exponential. We bring the coefficient down. The e term, because it is an e term, comes down exactly the same with no changes. If you see all of this and you're like, I'm just bringing that down, I haven't taken the derivative of that yet, don't worry, we will, it's just not the right time. It has to come down exactly as is, and then we will take the derivative of that term and stick it on with multiplication. This derivative has 2 pieces to it, right? It has the 9x squared, and then the plus 4, you need to make sure that you put this in parentheses if it has more than one piece. So things we could do with this answer, while this answer is absolutely correct, because it has all the pieces, what I would probably do in this case was I would take this 7 and distribute it to both of these terms. And I would have, let's see, 63x squared plus 28. So I did the 7 times those. It would need to be in parentheses. And then I'll have e to the 3x squared plus 4x up here. Let me see. I got to chat. I got to pull it up. Chat. Yep. So we got the 9 by using the power rule. So we had the 3x cubed. So remember the derivative of that, the 3 stays because it's coefficient, and then you bring that other 3 down. And so that's how we got that 9 with our x squared.
So going back to the last derivative on that, wouldn't it be 3x cubed to the 4x plus 4x?
Oh, yeah, sorry. I put a squared there. Yeah, in the last line, yeah, you're right. That power didn't get taken down for any purpose. That was just me making a mistake. So you guys, and I know I keep saying it, and I said it Monday a billion times, but I mean, in this example, what did we do? We used the exponential rule, the new one, but we also used a lot of old rules too. We used power rule, we used chain rule. It just, they all build on each other, and you never stop using any of them, especially power and chain. You'll notice, and probably like the fact that as we go forward, we don't use the product rule as much or the quotient rule as much. We just don't deal with a lot of functions that need it. There will be some that do, so it's not like you just want to, you know, toss it out of your brain or anything. But power and chain, you guys, those are like the bread and butter of this class. So you want to be really, really good at those. Okay, so let's talk about some natural logs. So remember the other special function we looked at on Monday was the natural log. It's the only logarithmic function we look at. So if you have y equals natural log x, what happened when we took the derivative was our derivative ends up being 1 over x. So basically, whatever you're taking the natural log of in your original function, you put a 1 over it to get the derivative. So this is the basic rule. And then we obviously build on that, you know, with some chain rule, with some, you know, whatever power rule involved, like in an example like this. So what if it's not just x in my natural log statement? What if it's the natural log of 2x plus 3? Well, let's see what happens. Just like with the exponential, the fact that we had an e in the problem governed the way we took the derivative, right? It told us what rule to use first. Same with the natural log. Because it's a natural log problem, I have to use the natural log rule before I do anything else. So think about the basic version, natural log of something, natural log of x, and then I took the derivative and it ended up being 1 over that thing, 1 over x. Same way here, it's just more than x. If I'm taking the natural log of 2x plus 3, when I take the derivative, I'm going to get 1 over 2x plus 3. But because this is not just x, of course, my chain rule comes in. But I always do the chain rule second. You guys don't let this affect the basic function in the problem. You know, don't let it affect the fundamental rule that you have to do first. I did the natural log situation. Now I can say, oh, but that's not x, it's 2x plus 3. So I do need to take the derivative of 2x plus 3, which is just a 2, and stick it on the back with multiplication. When you are multiplying here, so every time you have a natural log derivative, you know you're going to get that fraction. So it's always going to be 1 over something. When you're multiplying this term, no matter what it is, remember that term's going to be a top term, not a bottom term. So 2, for example, I could see that as 2 over 1. And I'm just going to put them together, which basically says you put the 2 on the top and the 2x plus 3 on the bottom. And that's it. And you just leave it like this. Be careful, because I know every time you have fractions, you want to try to reduce or take something out of the top and bottom, cancel things out, you know, to make it more simplified. But you guys, terms, you have to be so careful with fractions when they have multiple terms, either on the top or the bottom or both. A lot of people, you see these two twos right here on top of each other and you want to cancel them out. I can't though, because 2 is not the only term down here I have to consider. The only time you can take something out of a fraction is if you can take it out of every single term. And when I say term, so, and that's another thing, and we're going to have to review our algebra anyway. Let's talk about what I mean when I say terms. Obviously, if I just had an x, that's just one term. 3x, that's also just one term. It's two pieces, but it's one term because they're hooked together with multiplication. But if I had x plus 3, you guys, in the concept of a fraction, I treat this as one term. They're grouped together like this. And so let's say you had x over x plus 3. Well, I can't do this, because if I want to divide the top by anything, I have to divide it by the entire term, just like they were just one thing. You know, like if you have x over 3x though, here's one term, you've got the x on top. Do you see why you can cancel these x's out, but you can't cancel these x's out? That's the whole thing, and that's what gets confusing, especially when we're doing fractions. You have to be so careful. Let me see, what if I had 3x plus 3 over x plus 1? There might be a way to do this one, but it's going to take some work. You guys, let's see if we can figure out how to reduce this fraction. Usually if you want to reduce a fraction that has, you know, multiple things added or subtracted on top and bottom, a good way to do it is factoring. So that 3x plus 3, what if I factored a 3 out? Could I now cancel out the x plus 1 terms? Yeah. So you guys, it's kind of like, notice I could take the x plus 1 away because this 3 and this x plus 1 were just multiplied. Anytime you're canceling or reducing something, remember that really equates to division. When I say cancel out or reduce or take something out, it's dividing something, right? The only time I can divide something is if it was multiplied. So you can see this 3 multiplied by the x plus 1. Oh, okay, I can divide it out and it leaves me with just the 3. That's why this one worked over here where we had the x over 3x. It was just 3 multiplied by x. So I could divide out the x and end up with like 1/3 on that one. But it's the same reason why when I had a plus here, I can't divide an x out of x plus 3. It doesn't, it has to be multiply to divide or divide to multiply. The plus and minus, that's where we get in trouble. So we have to be really careful. And the only reason I say all that is I get a lot of you know, like when I'm grading tests or something like that. I get a lot of work and you get to this line and it's beautiful and I'm like, yes. And then I get one more line where these twos are canceled out and then I'm like, oh, they, you know, they almost had it and then they did something that was illegal basically. So we want to be super careful. So let's do another natural log. Let's put a coefficient on natural log. We haven't done that yet. So what if I have 5 times the natural log of x squared plus 3x? Let's take the derivative of this. All right, this 5 is attached to the natural log statement, so it is a coefficient. So it is going to come down into my derivative. I take care of the natural log statement first. You have the natural log of something. Take the derivative by doing 1 over that thing. We can definitely put this 5 up on the top, but I'm going to wait and do that in a minute. Now, I have one more step, right? Because this was not just an x. I have to take the derivative of that. So the derivative of x squared plus 3x is 2x plus 3. So let's see what we have all together. Remember that this 2x plus 3 also will go on top. So on top, we have the 5. We can put that on top. We can also put the 2x plus 3 on top. And on the bottom, we have that original x squared plus 3x. From here, you could, you know, you could distribute that 5 if you want to. You don't necessarily have to. I probably would. I'd probably call this 10x plus 15 over x squared plus 3x. But there's not anything else you can do with this. So yeah, these two terms have x's, this one does, but you guys, you can't cancel out those x's. You can't divide an x out of everything because this doesn't even have one, you know? So you have to be careful. This is how you would leave this problem. Let's see. Okay, let's do some algebra review. Like I said, I want to get us prepared for the next section where we have to factor. I am supposed to assume, you know, as your teacher in this class, I'm supposed to be able to assume that you can factor already. You know, you've taken algebra before. When you get to this particular class, you should be good at factoring. But what I find every semester is that, sure, maybe some of you have taken algebra and you took it last semester and it's all fresh in your mind and that's great. Maybe you haven't taken this, or maybe you haven't practiced factoring since high school. You know, and depending on who you are, that could have been a really long time ago. So because I found that the factoring really is a crutch in this chapter 12 for people, I really want to give you a good review on it. So let's start. And when I say factor, there's a lot of different ways to factor, right? But the hardest way to factor is usually when you have a quadratic expression, you know, with the x squared, and you have those 3 terms, we call it a trinomial, and you have to do that reverse FOIL situation. You have to do it so much in this chapter. So let's start slow. So let me give you an example of what I mean. Okay. So you're going to end up with something like this, and you're going to have to factor it. It's going to be a step in, you know, one of these problems we do in chapter 12. So how do I do that is the question. And you guys, there are so many ways out there to factor, so many different methods. I'm going to show you the method that I like. It might not be the method that you like, and that's totally okay. If you're good here, then you're good here. Don't fix something that's not broke. But if you do have trouble, you know, then you might follow along here and you might like what I do. So when you factor, you know you're going to go from this that has 3 terms, either added or subtracted, and you're going to end up with something that looks like this. There are going to be 2 binomials in here. So you need to figure out these 4 values. The first 2, so the first term in each of these binomials comes from factors of your very first term here. Our first term is just x squared. The easiest way to factor that, you guys, would be x times x. You guys, anytime you're factoring, even if this has a coefficient on it, you know, sorry, you know when you factor this, both of these factors are going to be x. There might be some kind of number here at some point, and we'll look at that, but you're always going to split the x's. So I know the 2 first terms are x and x. So let's go ahead and put those here. Now, how do I find the last 2 terms is the question. Well, the last 2 terms, so this one and this one, are going to come from factors of your very last term. So this 3 in our case. Looking for us on this one, there's only one way to break up a 3, right? Because it's prime. It's just going to be 3 times 1. So because I know that it has to be 3 and 1 here, I could probably just write those down and move on. But sometimes I have choices. You know, what if that was a 4? And I was trying to factor it and I was like, it could be 2 times 2 or it could be 4 times 1. You know, a lot of times we do have choices here. So I need to make sure my choice is the correct one. So the way you know if you have the right factors here, I have 3 and 1, which again, I know we're right because it's the only choice. You can take these factors and add them together, and they need to equal this number here in the middle. So in my case, the 3 plus 1 is 4. That confirms for me that I have the correct numbers, and I can write a 3 and a 1 like this. Now, as far as is it plus or minus, well, if this is a positive 3 and this is a positive 1, it's going to be plus 3 plus 1. Okay, so that's probably the easiest example I could give you, but let's look at some more. Let's do x squared minus 15x plus, sorry, I got to think for a minute, 36. All right, so this one is going to start out easy. Sorry, guys. It's my left-handed curse. I'm touching all over the screen. This one's going to start off easy, like the first one, because here I just have x squared. There's only one way this factors out. It has to be x times x. So I'm going to put those here. But you guys, 36. I mean, there's a lot of choices here, right? 36 is a super factorable number. So what I'm going to do is I'm going to think of factors of 36, and notice the minus here. That minus does matter. When I'm trying to add these 2 factors up and they have to equal the middle number, it has to equal a negative 15. So what are some factors of 36? Well, obviously 6 times 6. And I know this is not going to be the one, but let me walk you through my thought process. Is there any way that 6 and 6, either 6 plus 6 or 6 minus 6, could add up to be negative 15? I don't think so. So you guys, 6 times 6 ain't going to do it. What about 9 times 4? That's 36. So is 9 plus 4 15? No, 9 minus 4 isn't 15 either. So there's no combination of 9 and 4 that are going to get me that 15. So I'd say no, not 9 and 4. What about 12 times 3? These are factors of 36. And 12 plus 3 is 15. So you guys, I think I found my winner. You guys, so I'm going to put a 12 and a 3 here. Now here's the deal. This 12 and this 3 have to add up to be negative 15. But they don't. They add up to be positive 15. You guys, and this 36 here has to be positive. So what if I do this? Is negative 12 times negative 3 still positive 36? I think it is. And when I add negative 12 plus negative 3, I get what I'm looking for here in the negative 15. So not only did I have to pick through multiple options of factors, I also had to think about the sign that I was putting on those factors. So you guys, this is going to be x minus 12, x minus 3. All right, so let's look at another one. You guys, let's put a coefficient on the x squared. Let's do 4x squared plus 9x plus 5. All right, so this is where they get more complicated because more things matter. We have to be more careful. Possibly have to be more careful. But anyway, let's do this one. So we have a 4 now in the front of the x squared. So my two first terms, that x and x, it's not just as simple as x times x anymore. Because not only do I need the x times x as factors of x squared, I have to think about factors of 4 too. And put those on as the coefficients of those x's. So I could go one of two ways here, you guys. I could do 2 and 2, or I could do 4 and 1. You know, I'm gonna, you just pick one. Maybe it's 2 and 2. Maybe that's the answer. And I'll show you how to find out. But the 5, at least that's easy, right? That's got to be 5 and 1. Notice this is a plus here and a plus here, so I know I'm not going to have any negatives involved or anything. It's just going to be positive 5 and positive 1. This one, hold on, guys. No, it's fine. You guys, is this one going to work out? Oh, yeah, it's fine. Okay, I'm confusing my own self on the problem that I picked to be confusing. Okay, guys, how am I going to know if these are the right factors? Sorry, that makes it look like they're negative. They're not negative. Oh, there goes my 2. All right, so remember when I did up here and I took these two factors and I added them together and they had to equal the middle? Well, I can't just take these two factors and do that. I can't check with just the last two. So you guys, this is how I check on a question like this. I check on the cross products. So here's what I do. I take this 2x, cross product with the times 1. 2x times 1 is 2x. 2x times 5, do the other cross product, and you get 10x. You guys, so instead of just being able to add the last two like these two factors together, I have to consider these two as well. And the way I do it is a cross product. It has to be a cross product, and I can't stress that enough. But I found my cross products, and then I add them together to see if I get the middle term. Did I get the middle term? I didn't. I got a 12. So one thing you might think of is, oh, well, maybe I've just got my signs wrong. Maybe one of them needs to be negative. But you guys, no version of 10 and 2 makes 9. So something is wrong. And it can't be with the 5 and 1. It has to be with the 2 and 2 that I chose for that 4. So let me do 1 and 4. It's my only other choice. Notice I wrote it as 1 and 4 and not 4 and 1. I did that for a reason. Because like I mentioned, I think before, when you do have a coefficient on x squared, order matters. And I'm going to show you why it matters so much. So I chose 1 and 4. Let's try it, you guys. Try it with the cross product. So now I have 1x times 1, and that's just 1x. 4x times 5 is 20x. You guys, can you think of any combination of the number 20 and the number 1 that are going to make a 9? Because I cannot. So I'm like, what's the deal? It has to be 5 and 1. I already tried 2 and 2 on the other side and it didn't work. So now I did 1 and 4. So what is the problem? I'll show you the problem. Order matters. That's why we do cross products. Because it matters which term over here is with which term over here. See, those are looking like negatives again. That's not my goal. I think I'm just trying to point to numbers. Okay, let's try the cross products this time. 4x times 1 is 4x. X times 5 is 5x. You guys, I think we got a winner. 5x plus 4x is 9x. That is exactly what I'm looking for. So it works on the cross product, which means not only do I have the right numbers, I have them in the correct order. But here's where you have to be very careful. Every time you write down your factors, you write them down straight across. The only thing we do with the cross product is check. So we cross to check, but just like we did up here, we write down all our factors straight across the row. So you guys, the point is the 4x and the 5 and the x and the 1, those are the correct numbers. But if you had them in the wrong order and ended up with 4x plus 1 and x plus 5, if you FOILed this out, you would not get the term we started with. So it's the wrong factoring. So it's all about order. You guys, other ways to factor harder ones like this where you have a coefficient on x squared, some people use like grouping. If you slide and divide, if you have heard of that, just, I will say most mistakes happen when people try to do that because they forget steps. I am not going to teach slide and divide. But whatever method you like, as long as it works, guys. That's what really comes down to. Make sure it works. If you're worried about your factoring, you're worried about if it worked or not, if you're worried about your answers, what's the easiest way to check? FOIL it back out. See if you end up with what you started with. And that might seem time consuming, but you guys, if you're worried about your factoring and it, you know, if your whole problem hinges on that factoring, it's probably not a bad idea to FOIL it back out, see if you get back to where you started. All right, we'll do one more factoring and then we'll be done. So notice, again, we really didn't learn anything new today, but I think that's all right. Let's do 12x squared minus 5x. Let me think for a second. Oh, yeah, that'll work. Let's do minus 3. Okay, so let's start. Factors of the first term. We have multiple choices here, right? Actually, I'm going to let you guys lead. What do you want to use for the factors of that 12? Anybody? I mean, I got I got 3 and 4, I got 6 and 2, I got 12 and 1.
Let's do 6 and 2.
Okay, let's do 6 and 2. Let's do 6x and 2x as factors of the first term. It has to be 3 and 1 here. You guys, when this term is negative, one of these factors has to be negative, right? So I'm just going to stick it on this 3, and we'll see what happens. Okay, so cross-check. 6x times 1 is 6x. 2x times negative 3 is negative 6x. Uh-oh, we got a 0 there, which is not a 5. There's a lot of things I can change here. You guys, what if instead of the negative on the 3, I put it on the 1? Let's see if that changes anything. I don't think it's going to. But let's try. So then this would be negative 6x, and this would be positive 6x. Oh, and I still got the 0, so it's a problem. So you guys, it looks like that's not going to do it. But what's another thing I could change? What if I change the order and do 2 and 6? Well, let's see if that's any different. And I already have the negative on the 1, so let's leave that. 2 times negative 1 is negative 2x, and then I have 18x. I don't think the 18 and the 2 are going to get us anywhere. Even if I change the negative, it would just bring it up here. So you guys, once I exhaust all my options for these particular numbers, I have to try different numbers. So what's another set of factors of 12 we could try? Let's try 12 and 1. Wait, do I want to try 12 and 1? No, it's going to be so far. Let's try 3 and 4. More specifically, let's try 4 and 3. And let's put the negative on the 3. All right, so let's see what happens. 4x times 1 is 4x. 3x times negative 3 is negative 9x. When I add those together, what do I get? Yeah, perfect. It looks good to me. You guys, it looks like I have the negative in the right place, and I have the right numbers, and they're in the right order. So as I write them down, straight across, I get 4x minus 3 and 3x plus 1. So I'm really glad that you did the 6 and 2, because I really like going through the possibilities, because you really get to see, okay, this doesn't work, but why doesn't it work? And how many ways can we switch it around? That's what makes this a little bit harder, you know, than those first problems we did. But you guys, hopefully that brushes you up on factoring, and maybe answers any questions you have lingering about natural log and exponential stuff. I know that's still new. You're still going to be getting used to it. I did give you a lot of homework problems on that, so sorry about that, but it's good practice. And that's all I have for you now. We are going to be in class on Friday, and we will be starting chapter 12. So if you are my in-person class, definitely do everything you can to try to be in class, so we can, you know, you can get as much as you can out of it. Okay, all right guys, I'm gonna stop it. So I will see you guys later.